Testing 1, 2, 3. So let's begin by reviewing something that we learned yesterday. When you have a positive exponent, that means that we are looking at the limit as x approaches that number from the right side. And when we have a negative exponent, we are looking at the limit as x approaches from the left side. So let's take a look at number 1. The limit as x approaches 9 from the right side, h of x approaches negative infinity. And the limit as x approaches 9 from the left side, h of x approaches infinity. And remember that when these two numbers are not the same, the limit as x approaches that number, which is 9 in this case, h of x does not exist. It needs to be the same on both sides. Your left and right hand limit need to be the same in order for a limit to exist. So let's take a look at number 2. Number 2 says the limit as x approaches 2 from the right side, h of x approaches 3. And the limit as x approaches 2 from the left side, h of x approaches 1, which again means that our limit when x approaches 2, h of x approaches nothing. It does not exist because these two are not the same. Now let's take a look at number 3. Our limit as x approaches 4 from the right, h of x approaches 5, and the limit as x approaches 4 from the left, h of x approaches 5, which means the limit as x approaches 4, h of x approaches 5 because these two are equal. Now let's look at a new set of examples. So we have the limit as x approaches infinity of x cubed plus 2x minus 5. How do we know what this graph looks like? Well, first of all, we can see that by this cube root that it's the third degree, which means it is odd. So our function should look something like this. It's also positive, so it's odd and positive. So it's going to look something like this. So let's just make a little table and let's draw out our graph just to have an idea of what it might look like. So if we use points like, let's use 0. If we use 0, our y is negative 5. So we've got 1, 2, 3, 4, 5. We've got a point here. And we've got another point. Let's try negative 2. So we've got negative 2 cubed plus 2 times negative 2 minus 5. That looks like negative 8 minus 4 minus 5, which is negative 17. So let's make this negative 17. Oops, erase that dot. We have 1, 2. We've got one here. And let's do a positive 2. So we've got 2 cubed plus 2 times 2 minus 5. 8 plus 4 minus 5 is 7. So now we can do 1, 2, and 1, 2, 3, 4, 5, 6, 7. Got something here, so it looks like we've got a graph that goes something like this. Okay, so now let's take a look. As x approaches infinity, f of x approaches infinity. So now let's take a look at the next one. It says the limit of as t approaches 0, t to the 5th minus 4t squared plus 7t minus 8 approaches what? So instead of drawing a graph, when we have a number, you can actually plug that in for t and you will get your limit. So if we plug in 0, you get 0 to the 5th minus 4 times 0 squared plus 7 times 0 minus 8, you end up with negative 8. So our limit is negative 8. And just to be sure, let's just map this out just so we can see. So again, if we take some points, so we know that if we plug in 0, we get negative 8. If we plug in 1, we get, let's see, I'll do it down here. So we've got 1/5 minus 4 times 1 squared plus 7 times 1 minus 8. You've got 1 minus 4 plus 7 minus 8. It's negative 3 plus 7 is negative 4 is 4 minus 8 is negative 4. So let's see, and we know that this is also a odd positive function, which means it's going to look something like this. So we've got negative 8 down here, we've got 1, negative 4 right here, so we know it's going to look something like that. And as t approaches 0, so as our x, this is our x at 0. So as t approaches 0, f of x approaches 8. We can see that clearly right there. Okay, so let's look at our next one. The limit as x approaches negative infinity, g of x approaches what? And they tell us that g of x is 18 minus x squared. So we can look at this as the limit as x approaches negative infinity, 18 minus x squared approaches what? So let's make our graph again. So we have our x and y chart. Plug in 0, we get 18 minus 0 is 18. Plug in 1, you get 18 minus 1 squared is 17. So we know that this is a parabola, right? It's an even negative, which means that it's going to be down and down. So we have 0, 18, as well as 1, 17. Again, I'm just estimating these points. And if we were to put in negative 1, we would also get 17 there, so we would be right here. So we know that we have a parabola like this, and we can see that as x approaches negative infinity, f of x approaches negative infinity. Now let's take a look at some graphs. So in this problem, it gives us a plain grid and it gives us some information. We have the limit as x approaches 1 from the right side, f of x approaches 2. And the limit as x approaches 1 from the left side, f of x approaches 2. Therefore, the limit as x approaches 1, f of x is 2, and f of 1 is 2. Okay, so let's take it one step at a time. So we know that the limit as x approaches 1 from the right side, f of x is equal to 2. So let's look at that point. Let's look at 1, 2. So I'm just going to draw a circle here because that's what we're looking for. Okay, so our graph could essentially look like anything. So from the right side, our graph, let's say it looks something like this, needs to come and end up here at 2. And we also know that the limit from the left is also 2. So let's make this going like this. So now we've got that. So now we've got this graph, and let's just make sure. So From the right, it ends up at 2. From the left, it ends up at 2. Okay, that all makes sense. So therefore, the limit as x approaches 1, f of x approaches 2. Okay, everything looks good so far. And now we have f of 1 is 2. And remember that this open circle means that it is not included. Therefore, we can color it in, and now it is included. So again, our graph could look like anything. It could look like this. It could look like this. It could look like just about anything as long as that limit is correct and the circle is colored in. So let's take a look at our next one. We're going to do some more problems like this. So again, we have a plane grid, and we have the limit as x approaches 1 from the right side is 2, and the limit as x approaches 1 from the left side is also 2. Therefore, our limit as x approaches 1, f of x approaches 2. Okay, so everything looks just like our other one, except that f of 1 does not exist. Now, so we just talked about that. So our graph could look like anything. We also said, so we have 1, 2, so it means our graph is here. And this time, let's make it a line. So now we have this. So at f of 1, it does not exist. What does that mean? That means that our circle here, that point 1, 2, is not included in our graph. That value does not exist, which means it is not included. So it should not be colored in, and this is exactly what the graph should look like. Okay? So our next one, again, plain graph with some information. So we have the limit as x approaches 1 from the right side is 5 and is f of. So let's take a look at our next one. So we've got, again, a plain graph, and the limit as x approaches 1 from the right side, f of x approaches 5, and the limit as x approaches 1 from the left side, f of x approaches negative 3. So therefore, our limit as x approaches 1, f of x does not exist because these two are not the same. And f of 1 is equal to 5. So which means this tells us that it's included. So we're going to have a colored circle. So let's take a look at how we graph this part. So we have the limit, I'm going to write it up here so we can see. The limit as x approaches 1 from the right, f of x approaches 5, and the limit as x approaches 1 from the left side, f of x approaches negative 3. So the limit as x approaches 1, f of x does not exist. Okay, so let's take a look at this. So we have our point. So we have when x approaches 1 is here, then f of x approaches 5, which would mean it's about here. Okay, and then we have as x approaches from the right side, we have that. Okay, you know what? I'm going to stop, do a new video since it's almost done.